of our pipe stress software called CAEPIPE, and CAEPIPE3D Plus is what we are going to cover. I'll cover this particular slide at the end once you've gone through the whole live demo. Now, what is CAEPIPE3D Plus? First question that comes up is it is actually CAEPIPE bundled with 3 other modules. What are the different modules? One is the data translators. And the data translators from various 3D plan design systems, where you take the piping layout, including pipe sizes, material properties, temperature, pressure, and support, where the supports are located, types of supports, all of those can be brought in from 3D plan design system into the stress module, which is CAEPIPE. And
I'm sorry, you can.
Okay. So the data translators basically take the data of the piping geometry, pipe sizes, materials, operating conditions, support locations and support types. All of that information can be brought in from 3D plan design system into the stress package. The first step, it goes to the stress package called check stress, which is nothing but a mini version of CAEPIPE. It's a micro version, you want to call it, or it's a very. So what we do here is check stress is directed towards designers. It is not for. So check stress is a module that is built into CAEPIPE3D Plus, where it takes the complete geometry and sizes and materials and operating conditions and performs what is called first level stress check so that the designers, the actual 3D piping layout designers, can see whether the layout is flexible enough to accommodate the thermal expansion of the piping. So that's the first step. What is happening in the world right now is the layout person does the layout, then it goes to the stress department. The stress department says, no, pipe is too stiff, too much load is going on the nozzles, too much stress is produced. So the stress engineer recommends changes to the layout. Then it goes back to the stress department, the layout department. The layout person again does the rerouting of the piping. Then again it goes back to the stress department. So it goes back and forth a number of iterations. So this whole thing can be avoided. So what is happening there is the check stress, it takes the 3D piping layout, then they generate the 3D designers generate the isometric drawing. Some people, the total isometric, or it could be stress isometric, and that information goes to the stress department. They actually create the stress model, perform the analysis, and if there's any loops or any changes to the layout to be done, it is done by the stress engineer, and this information has to be fed back to the 3D. So that whole process is a very cumbersome process. Now this check stress, what it does is, you're going directly from 3D piping design, you're skipping the isometric, you're going directly from there into the stress model. So by doing that, one is you are saving time, man-hours, and also when you are transferring the data from, by doing the routing of the pipe in stress software manually, you could create errors. You could, human errors may creep in. So this human errors can be avoided by going directly from 3D plan design into the stress package. So there are 2 great advantages. And so for some of the 3D system, any changes you make in the 3D, in the stress model, could be taken back into the 3D directly as what is called reference 3D geometry. And using those reference 3D geometry, again the 3D designer can make changes to the layout. So this check stress module is very useful for the designers. It can also be used by stress engineers at the beginning, and so that way the layout, when it goes to the stress department, it's almost code compliant. There's a good chance there won't be much change in the layout. Okay, and the next slide, then the next product that is built in is what is called the hot clash. As the name suggests, in the case of 3D plan design, when you are doing clash check or interference check, you are checking the interference of the piping with other objects. It could be other object, could be another piping. It could be an equipment, it could be a ducting, cable trays, steel, concrete, any of those. But it is doing the clash check as you design them. It is not accounting for the so-called the deformed shape or deflected shape of the piping. During operation, especially due to thermal expansion or contraction, the pipe is going to deform. That deflected shape, you want to make sure even that deformed shape will not interfere with any other object. This is especially true, you need this kind of tool when you are routing a pipe in a very congested area. For instance, let's say you are doing a submarine. Now you can, in a submarine, since space is extremely limited, it's a premium. And routing the pipe, making sure there are no clashes even during operating condition is a requirement. Again, in the case of nuclear reactors, again there are lots of piping going, that are routed inside the nuclear containment building, and again this space is extremely limited. So whenever you have a space constraint, and even some of our users are using it for aircraft, missiles and rockets and all that, where they check for they check for hot flashes used to check for interference between not piping. There's not much piping in these aircraft and spacecraft. There's a lot of tubing there, thousands of tubing, and also ducting. So they want to make sure there are no clashes between those and the adjacent objects. So again, this hot clash is useful. But only thing is, right now it works for only 3 systems: E3D from Aviva, PDMS from Aviva, and CAEPIPE from CAEPIPE Oy in Finland. So these are the 2 additional products, and of course you have the data translators. Next slide, please. The data translators. Again, the data translators are built into CAEPIPE3D+. One of those, you have the interfaces from E3D, PDMS, Tribon from Aviva. CADmatic model can be brought in, PDS and Smart Plant 3D coming from Hexagon, and Autodesk Plant 3D, Bentley's 3D model, as well as number of software like SolidWorks, Solid Edge. They produce what is called PCF file. PCF file stands for piping component file, so that piping component file can be brought into the CAEPIPE as well as CAEPIPE3D+. There are 2 arrows there which are in blue. Now go back, please. Karthik?
Yep.
Go back, yes. There are 2 blue arrows where any revised model coming from any revised stress model coming from CAEPIPE3D+ or CAEPIPE can be sent back to E3D and PDMS as well as CADmatic as a reference solid geometry, so that the designer can reroute the pipe using those reference layout there that he got it from the stress engineer. So those are the 2 blue arrows that are built into this our product CAEPIPE3D+. Next slide, please. Is our CAEPIPE, also CAEPIPE as well as CAEPIPE3D+ has number of translators or interfaces where we can take the fluid transient data from PipeNet, from FlowMaster, that is, and as well as taking the geometry from CAEPIPE into FlowMaster. You can take the geometry and the complete stress model from Autodesk PipePack. It's no longer alive, but enough input files are sitting there in the world, so we do have a translator to pick up, take the PipePack directly into CAEPIPE, and you can also go into IsoGen for isometric drawing, detailed drawings, and you can also take the model from Caesar 2 into CAEPIPE. Now you can also export Caesar 2 model as well as DST pipes model. DST pipes is used for nuclear piping analysis. For instance, only Hungary has got parks. I don't know about Czech Republic, what nuclear plant you have. So anyway, you can take the model from CAEPIPE, CAEPIPE3D+ into Caesar 2 and pipe stress. But the red ones are, as you can see, these are optional, so they are priced. They are not freely, they are not built into the software as a free module. Next slide, please. live demo. So now I have finished my presentation on CAEPIPE3D Plus.
Thank you very much for the detailed introduction. Good morning to all. And for today's presentation or today's webinar, we are going to be using two products. One is the E3D, you can see here, and then the other product we are going to be using is the PCF file, which can be coming out of your Smart Plant 3D, AutoCAD Plant 3D, or Bentley Open Plant, Auto Plant, CATIA, any of those softwares. So let me start my presentation from the E3D. Here is the model. You can see this is a suction line which is going from a tank. You can see the nozzle is connected to this tank, and then it is going and connecting to these two pumps. You can see one of the pump is here, the nozzle, and then there is one more line again coming and connecting to this. Now how do you do the CAEPIPE3D Plus on this? And if you see, there is a menu. You have this CAEPIPE3D Plus on E3D. You just click on that. That brings you the interface, and here you can select and or answer the basic information that you would like to include in your analysis. For instance, it is asking you a question: when you created the model, in what units you entered your pressure values, the temperatures, and the weight of components. And then it is also asking like what analysis code you would like to use for the analysis. Here's the list of codes that are available in CAEPIPE and CAEPIPE3D Plus are all listed here. At this time we have more than 21 international codes, including ASME, European, and RCCM, Quality, and all that. Then you can also, in case if you are using any hangers, what type of hangers you would like to include as a default hanger type in your analysis. Again, the list of hangers that is available are all given here. You can select those, and then it is asking you how you want to transfer your model, in what units, SI units or English units. You can select them. Then your fluid information in terms of specific gravity with respect to the water, and let's say you are using oil as the input, so then you can specify what is the specific gravity of oil with respect to water. Then of course it is just asking you what is the node numbers you want to use, the starting node number, and what is the node increment you would like to use. And then when you are doing the analysis, a lot of time what happens is you might also have instrument tappings, pressure tappings, and all of those. They are very small bore pipings. If you don't want to include them in your analysis, you have an option to exclude them by giving a filter here. For instance, if it is greater than 0, then it will include those values also into your analysis. So anything less than what value it is given here, those will be excluded from your analysis. And then when you do the analysis, how you'd like to use your vertical axis in terms of whether your gravity is acting in Y direction or it is in Z direction, you can always specify through this. See, in generally what happens is in 3D plant design, you all know that Z is always the vertical. But when it comes to stress analysis, in case if you would like to use the Y as your axis, then you can actually turn it on, where the layout remains the same, whatever you have, but then the axis accordingly will be rewritten there. Specify how you would like to transfer certain elements, like for instance rigid elements. When you have a 3-way valve or a 4-way valve, how you'd like to transfer them into the analysis software, you have an option here. You can choose one of the option. Then it is also asking you how you'd like to transfer the support, the boundary condition, which you have inside your 3D plant design software into the analysis software. And again, there are two options are given there. We will see that in detail later. Then you can also specify how you want to transfer the flanges and the anchors in terms of nozzles. And then once you have that, here's the list. Okay, let's say you want to transfer this piping. So you just click on that, or you can navigate through the list and you include in your scheme. And let's say, now let's see what is happening with this layout, where we will only take the nozzles where it is attached to the equipment. There are pumps and the vessel, and let's do the quick analysis. See, these are all done by the designer. Designer is doing in front of you. Assume me as your designer, and it just does a quick analysis, and now you can see it is giving you the result of the selected layout, and the designer sees there are lots of red here. And in terms of boundary condition, you can see that we have included only the nozzle attachment and none of the other supports. Now the designer is given an option for him to see what is happening on the deflected shape. So now let's say when you do the animated shape, you can understand, or the designer can understand, the pipe wants to expand. See, it wants to expand, but because you anchored this end and there's not having enough flexibility here, this portion is bent completely, and that in turn is producing a lot of expansion stress. So as you know, generally the layout is decided by the temperature, and since you don't have, you can see that there is no support there. That less support you have for expansion, which is actually good for the piping. So without any support excluding the anchors, you can see still it is creating lots of red in this area, giving an indication to the designer that he or she has to reroute this piping to make it more flexible than what it is. So that is what is happening by looking at these deflected shapes, and also the stress contour plot, which is given only in terms of color graphics code. The designer can just understand there is some issue with the piping. And if you notice here, there are no numbers are given here, because a lot of designers may not understand and what is the meaning of those numbers. But by looking at the color coded graphics, they know that there are some issues there. Red means there's danger. If they are within the say yellow zone, that means they know the piping layout is safe. So now, since he or she has the access to the piping layout, he can always go back and then see what he can do in terms of the layout, making it more flexible. Let us assume, let me bring the revised layout. So I remove that layout, and let's say there is a revised layout is also stored in this. This is the revised layout, and if you see, the designer has, instead of coming and directly joining here, so basically he has rerouted the pipe to make it more flexible by adding a bend here and also another bend here. The T what was here has been moved here. So by just adding this bend and this bend, you are making it, this portion, almost symmetrical. So by adding this flexibility, you will eliminate the problem what you have seen earlier. Now let's see what is happening on this again. Let's take this and do a quick analysis again. And now you can see the expansion wise, they are all blue and green. And now the designers can again go to the expansion deflected shape and again see it is freely growing, and the bend what is being added here and here, which is making the pipe, made the pipe more flexible, and it's allowing the free growth of the pipe in this direction, and because of which now you can see the whole expansion stress is all gone here. Whatever you had the red region, they are all disappeared. And now the designers can also, now since he has finalized the layout, he or she can now fix the or carry the weight of the piping, and also fix some of the supports to take care of the occasional loads such as wind and seismic, and then again give the handover the detailed stress model to the stress department for them to do the detailed analysis. Now let's bring the support in. So I'm going to bring the support condition by using the attributes. See, you have all these flexibilities to include and exclude during analysis. So now you can see the supports are also brought in by turning it on. Now expansion we already seen, by adding extra support it did not affect the expansion stress what we had earlier. Now the designer is looking at what is happening on the weight case, and now again weight case they're all fine, no issues there. You can see that it's all blue and green, and you can also see what is happening on the seismic case, static seismic in this. So again the same support scheme what is being used are able to handle that. So in case if you want to see what is happening on the reflected shape, again you can see that and you can animate it. So they are all fine. Since you can always magnify that. Here's the operating deflected shape. So again you can see they are all beautifully operating. And if they want to review what is happening on terms of status of the resting support, for instance, if you see here is a resting support added. Basically, in case if you remove this pipe from this connection, equipment connection, you need to have some temporary support, and for that support this is the one which has been added. Now he or she can see what is happening on this resting support by looking at this option, where it will give you, it is saying even during operating case this pipe is resting on the support, and because of which you see there is a weight load acting on those supports. So which means this supports not just a temporary support, is also acting as a real support in this particular model. So all such things can be seen through this option called status of resting support. Then you can also understand what is happening on the nozzle loads by going into the nozzle summary. When you click on that, it is giving for all the load cases. It is giving the what is the maximum and also what is the minimum for each anchor nodes. You can see that. As you click, it shows on the right side. It is also giving you a summary, nice summary here. In case if you get an allowables from your manufacturer, those can be input here. Then it will also do a quick check to see whether those allowables are greater than the computer loads. So that's also possible. And once, let's say, everything is done and you want to hand over the stress model to the stress department, you can just use this edit layout option, and then you can save. So I'm going to save this file. And now you come out of the software. Now you are done with your 3D. That means the software being used on top of the E3D and given to the stress now. And as a stress engineer, they can launch the same program here. Now it is an independent one where you are not using on top of 3D. So you just click on CAEPIPE3D, which is same as your CAEPIPE interface. Now let's open the model file. And this is the model which we created. Now this is the CAEPIPE interface. Many of you are familiar with. The left side what you see is the layout window, and where as you scroll you can see it is highlighting the corresponding element on the graphics on the right side. They are all synchronized. And if you don't have any 3D model or 3D software with you, you can actually use this interface and you can build your own layout by going into the options that are available with CAEPIPE. For instance, how do you begin your modeling in CAEPIPE? Here's an option. You can first define your what is your analysis code, like what you saw in the interface. All the analysis codes are all given here. You can see them. Then the next option is you can specify what units you want to use to build the model, and of course you have given a combination of English, SI and metric, or any combination as a user defined. And of course when you are doing your actual modeling, in case if you get some information in different units, in the middle of the project you can still change that and automatically it will change. For instance, if I change everything to SI, it can change to SI. If I change everything into say English, it just changes in front of you. It's just so easy. Even during the middle of the analysis you can change your input, or even viewing the results you can change these units as you want. Okay, let me go back to what I had, all SI, so that easy to understand. And this is the CAEPIPE interface. What type of elements that are available in CAEPIPE to build the model, you click on this, it gives you all the element type that are possible. Of course you can see pipe bend, miter bend, valve, reducers, bellows, everything. All using these components you can build your layout manually without even depending on your 3D software. And what kind of data you can have in terms of flanges and supports and all that can be seen through this data option. These are the data types. You can see like anchor, concentrated mass, flanges, guides, skewed restraint, rod hanger, user hanger, all of them you can see here. These are the different type of data we call it as. It can be like a support also, and those can be fed through this. And how do you input material? You click here, they are all here. You can input this, or you can select from the material library which is available into the CAEPIPE software. Okay, let's say for instance when you go inside the CAEPIPE3D or CAEPIPE, you see there's a whole material list of libraries are available. You can choose from here. For instance, the latest material library for B31.1, it is 2020. You select it, then it gives you all the list of material which is input already into the library from the code. they are all available here. You can choose them. Similarly, you have an option to enter your section properties. All these are directly come from 3D because we use the interface, and that's why all these information directly brought in here. Otherwise, you can manually input it by using this option. Again, you have a library, ANSI library, DIN library, GIS and ISO. Then in terms of standard pipes, you can see all of them. In terms of schedule, what you use, let's say for instance if you say 3-inch, then all applicable schedule in terms of wall thickness can be specified again from the library. Since we brought in directly from 3D, they are all showing up here. You don't need to re-enter them here. In terms of load, you click here. Here is the where you can define your temperature, pressure, and what is the design temperature and design pressure. In this particular layout, there is only one temperature and one pressure. In case if you have more operating conditions, you can always turn on by just going into this analysis. Then you go to temperature. You can specify how many thermal loads you have on this piping system. See, in case if you say I have 2 operating conditions corresponding to 2 pumps, you can just turn it 2. Then immediately when you go into the loads, you will see that it will show up another load case here. The shade is 150. It's my second operating case, and assume the pressure is 15 bar. You can turn it on. See, the moment you do this, now you go into the loads. Immediately load cases, it will show automatically the new load case that has been added. You can also include that for your analysis. When you are done with that, you can just save this. And then here it is again in terms of other load cases like static, seismic. There are 4 winds that are possible. You can also input spectrum, time history, the harmonic analysis, and also there are other options that are available with CAEPIPE. You can see in terms of, you can include in analysis the pumps, compressors and turbine qualifications, and also you can do your piping component qualification by going into these internal pressure design and external pressure design. In case if you want this wind profile to be used based on these codes, you can also do that using these options. And with this features, all the features what is available with the CAEPIPE. Now let's say we save this model with the new load case included. Now you do the analysis. And this is the interface again you see now. Here it is, all the numbers are actually given to the designers or the stress engineers. And here it is a code compliance where for each load case, like the first one which says sustain, which is the weight case, for that it is giving you the highest ratio, the stress ratio we call it as, on the top. Then as you go down, you can see they are going down. So which means by clicking at that node, you know the highest stress due to the weight is at this location, which is at node 240, and which is 0.22, you can see it. And all others are less than that, confirming that the layout due to the weight case are passing the code compliance. Similarly for the expansion case, you can see it here. Here it says at 80, node number 80, that's where you have the maximum, which is at the reducers. And again you can see the color coded graphics. That's why you have something which is yellow here, which is closer to this region. And again, the moment you select expansion case, since you have 2 operating cases, it is actually finding out at each node the combination of the expansion 1, expansion 2, expansion 1 minus 2. So it is finding out the range, and it is finding out the worst value among the 3 load cases and giving you the maximum which is on this node at this location. And if you see, the rest of the things are all less than that. Similarly, it is doing for the occasional case. The occasional could be wind, seismic, or any kind of dynamic load you may have. So again, it is finding out the worst of all the cases, all the load cases that you have in terms of occasional load, and that is what is displayed on the top here. This is with respect to the node data. Now again, code compliance, you have one more which is element wise. When you click on that, same information, but it is not shorted here for each element, like going from 10 to 20. See, this is the node, it's going from 10 to 20. It is giving you the weight case, the expansion case, and occasional case. So again, as you click or as you scroll, you see that it is showing that particular element on the graphics as you go along. Then you can see the support loads, and again support loads, it is giving for all the anchors for the empty weight case what are the force and the moments. If you want for other load cases, you click this button and you click anchors, and here again you can say for operating 1 I would like to know what is the force and moments. You can choose that. This is what is called the support load. Then you also have another case which is called support load summary, where it is taking one support, one particular support. For that support, for all the load combinations, it is giving you the force and the moments. Similarly, let's say you want to see what is happening at node 240, which is a limit stop. You click on that. Again, it gives you for that support, for different load cases and combination, what is the maximum, the minimum loads, including the frictions. So that's how you can use your support load summary. It will be very useful for your support design. You can give this information in terms of CSV file to your structural department for them to design the support. Again, you can see the element forces. When you click on that, again you can choose the different load cases. Let's say you want to see what is happening on expansion 1. You can see that it is giving you the force and moments for all the elements. And it is also giving you the SAF what is calculated based on the code equation chosen or the piping code selected for the analysis. It is giving you the what is the value, and it is also giving you the flexibility factors what is computed for different elements, and it is also giving you the stress on the right side, actual computed stress at each element. Same thing you can also see for expansion 2, expansion T1 minus T2. So all that is giving you. So what you see in the sorted stress is the max of all the 3 at each node. That's what is shown there. You can also see the displacements here. So again, this is for the, let's say you want to see operating load case 1. You can see the deflected shape and also the animated deflected shape. Both you can see. Now, let's say you want to generate a detailed stress report to present to your client. You can go here. You can print. You can select whatever information that you would like to include in a stress report in terms of QA block, options, layout, details, what materials used, section, loads, and what are the load combinations that you would like to present in terms of analysis, like operating 1, sustain, and say seismic. Then the results, what are the ones you want to include? Let's say you want to include these, and then other information like center of gravity, bill of material, you want to include table of contents for easy reference. Then once you are done with that, you can actually click on preview. It gives you a nice report with tabulated like this. You can see them. No software gives you so nicely tabulated results like this. These are all inputs. As you go down, you will see these are all outputs for different load cases are nicely printed here. And the table of contents shown in the preview at the end. When you print it, you will see that it will come in the front. And here is the output, nicely printed here. See, the table of contents comes here, and it gives you all the page numbers for each report. They're all nicely plotted. When you go to the end, you will see the bill of material also included in your stress report. That's how all that can be done. And in case if you want to use this output for your further processing or any other thing, you can always go to print again, and you can print as a CSV file instead of a PDF file or hard copy printout, for which you can use 2 files. There are 2 options there. You can create as a text file or a CSV file, which means it's a Microsoft Excel format. You print it. Now again, when you go there, you have a CSV file which you can use it for your further processing. The whole printout nicely tabulated and given you. This is also available. Then in terms of graphics features, again you can also plot the graphics. Let's say you want to plot this printed graphics or the rendered graphics. You can go to print command here, and you can see the preview of this. You can print it, or if you want to create a soft copy file in terms of where you want to take it to AutoCAD and edit it, you can go to file, print, you have print to file option. Here there are a whole list of options available including the DXF. So wherein you can create a stress isometrics and all that using this option. So this is about how the CAEPIPE can be used independently, or CAEPIPE3D Plus can be independently used without having the interface to the 3D. So which means the same software is working in different modes for you. The first mode is the designer is using on top of 3D, and then the second option is the same software is being used by the stress department independently without having any dependency on the 3D, and creating all kinds of report that they independently did it in order to submit the report to the client. And this is what we have seen. Now let's go back into the again CAEPIPE3D Plus, where I'm going to be showing another option of using the same interface on the PCF files. How do we do that? You click here, you have CAEPIPE3D Plus, you have CAEPIPE3D Plus for PCF. Click on that. The interface will be slightly different. Of course, it is asking you the same basic questions like what you saw with E3D. And now you select your PCF file coming out of any 3D plan design software like we have shown in our PPT. Let's say here is a model, I'm just selecting it, and again you can fill up the details it is asking, and then you can say do the analysis for me, and it does, and it shows you that same interface again. Now in this one, if you see, this has hangers. So the moment you have hangers, you will see this option shown up which is called hanger report. When you click on that, it shows you what are the hangers being selected or by the CAEPIPE based on the type defined by the designer in the PCF file. You can see that. So again, when it comes to expansion stress, we are very flexible, no issues there, everything is all blue and green. And the sustain case, again the same existing supports are able to handle that. Then they can also see the source summary. For instance, in this case, these are two equipment, and the equipment manufacturer has given the allowable, which is also input into the 3D plan design, which is brought into the CAEPIPE3D via PCF. You can see it. We didn't enter anything, as you know, it directly came from that. You can see the forces and the moments given by the equipment manufacturer for this equipment. Similarly, there is another equipment here, which is here. Then you can also see they also input the actual displacement, thermal displacement at this piping layout, where the equipment itself is moving by so many inches. Even that is also input, and again that information, when you go into edit layout, you can see them through the specified displacements. You can see that these are also brought in. Again, in terms of information, you see the similar info here. When you go to list command, you can see all the bends are directly come from the PCF file. Then you can see the flanges, their weights are all directly come from PCF file. You have valves here in this. Again, the weight of the valves are all transferred directly from your 3D model via PCF into CAEPIPE3D Plus. Then you can also see your branch SIF in terms of these are all welding tees. So all that directly coming from your 3D plan design into CAEPIPE3D Plus. So you are not entering anything manually here, which means you can save huge amount of man hours and then checking times and all that by going into intricate details of it, because it's completely automated here. So again when you press the analysis, that's how it is giving you the complete stress. If you want to see the detailed report, you click on view detailed stress results. Here it can give you the numbers also. You can see that code compliance. So again you can see hanger report. This is a toggle switch. You can use this to see all that. So it is the full version of CAEPIPE sitting on top of your PCF interface. And the next one, let's say now I've just also covered your how the PCF file is all brought in, or the information from 3D plan design has been brought in. Now let's talk about the hot clash. Then I will show you some more intricate details. Now let's say here is another line which is a discharge line, which is going from this pump, and then it is going and connecting somewhere in this area, in this region, that piping. Okay, so these are the two lines. And let's see what is happening when we do the hot clash on this. So I'm going to select that. There are two discharge lines. I'm going to include both of them. Now you can say apply. Now you can see the layout is fairly flexible. That's why you don't have any problem with your expansion stress. Now let's see what is happening on the weight case. See, the moment you select weight case, now it is showing to the designer that this line is fairly good because you have two supports at least to take care of that, or at least this and that is able to handle this. Whereas this pipe has a long overhanging area, overhanging length, and because of which you see there is a lot of red here, giving an indication to the designer that this may not be sufficient for you to handle the weight of this pipe. Now how do you see that? Again, go to sustained reflected shape. You can see that, see, this is reflecting quite a bit. So it is only an hypothetical, just created just to show you like how the hot clash can be used. Now let's take this deflected shape, take it back to the 3D, and then see what is happening on the 3D in terms of deflected shape. Here's an option, export deflected shape. Click on that. I call it as discharge line, and you want to take it back to PDMS or E3D. And come out. Now let's say we want to import this and see what is happening here. You can see the deflected shape. This is the original pipe, and this is the deflected pipe which is brought in back by after the analysis. Now this is the operating deflected shape or sustained deflected shape. You can see the pipe is deflecting quite a bit, and those are all brought as a reference geometry. Now the designer can actually do the hot clash here, or you can do the clash check using the E3D software, and then what you can decide on what is going to be happening on this pipe. If you need to add more support, you can add support, and again you can try that. This is how the hot clash works. Now in terms of how these interface is working, what kind of customization possible. So let me just show you a quick glance on the product manual. This is the product manual which is available in the installation folder of the CAEPIPE3D. Plus there's a folder called manuals. When you go inside that, you see this manual. When you go to the table of contents, it is all explained in a very detailed way, like how this can be used by the designer. There are some examples are given here with a detailed write-up and examples. Now how do you configure this CAEPIPE3D Plus for PDMS or E3D? There are number of topics given here. How do you configure that in CADmatic? Again, from the installation to the all the way to the reference, they are given there. How do you do with other software which is coming or able to produce PCF file? Again, you can see them here. Now how you are doing mapping of components when you are having something in 3D, how you are bringing them inside the stress analysis, they are all described here in this. You can see that. That's why it's called component mapping from 3D design software to the stress. And how that material information is coming, again you can see here, they are all having a nice topic here. Then how you are bringing the support types or the support, the physical configuration of support which is represented in 3D, how they are coming into the stress analysis as a mathematical support, they are given here. For instance, if you say without using mapping DB, how do I do an attribute? When you click on that, they are all explained here. Transfer supports, how do you transfer the hangers, what is the syntax, and there's an example given here. Now at the end they are all summarized like a nice table here, and all they have to do is the designer has to input this attribute into the 3D plan design system at the support location. You can see if it is an anchor, what is that needs to be filled. If it is a restraint, if it is a snubber, how it is. They are all defined here, well defined here. You can see them, all possible types. That's how it is translating into a mathematical support. Then in terms of component mapping, here. See how the pipe is transferred to 3D, from 3D to pipe stress, how the connector is transferred from PCF to CAEPIPE. They're all given here. They're all well documented. You can go through a glance of it. This is for the PCF. Same thing on the PDMS. You may have different type of components built into the 3D system, and how each one is transferred with a detailed elaboration is given here. You can read them all that here. So this is how it is doing it, and in terms of how it is being entered, support types. You can see that this is what the attributes are entering, and which is brought in into the stress package as hanger. You can see that. The left side, the information is what you are entering in your 3D system, and the right side what you see is how it is getting translated into CAEPIPE3D Plus. So this is how you can actually use these files in order to bring all the information whatever you have in your 3D system into the CAEPIPE for analysis and for report generation. So with that detailed introduction, so my presentation ends here. If you have any questions, you can ask them, and we are there to answer for those.
And first is, we are taking the model directly from 3D plan design into stress model, including geometry, supports, pipe sizes, materials, all of that, operating conditions. The more you put into the 3D system, the more information we can gather from, we can transfer. So thereby, we are avoiding errors. If you generate the stress model manual, you could have human errors creeping in. So that's the first point. Second is, by having this check stress module built into CAEPIPE3D Plus, which is directed towards 3D designers, it's useful for 3D design. You can do for most companies you go around the world, the stress people are the stress people, pipe stress people. Okay, that's because the layout they get is very stiff most of the time. Okay, and a lot of times what happens is the layout comes already saying that this is the final layout, and we have started procuring materials. You can't do any changes to the layout, etc., etc. You come up with a support scheme to take care of the loads. That's what the stress engineer is asked to do, and which is not an easy job. And ideal is to do it up front. It doesn't matter what it is in life, whether it's piping layout or it's housing, a big design of a building. It doesn't matter. The best is to do as much as possible planning and upfront check. Then it's easier downstream. Next is, you can check for clashes under various types of conditions, including hot operating conditions and shutdown conditions, header test, as well as for wind and seismic in 3D Plus. Then as the stress analysis is done, of course you save drafting maneuvers, because you're going directly from 3D plan design into stress model. The drafting maneuvers are all eliminated, and then you have one stress tool, which covers both the first level stress check by the designers as well as detailed analysis by the stress engineers, and that in turn reduces the software cost. And and at the end, I could say, for some of the 3D plan design, for which we do have detailed information about the how the piping information is stored in their database. We have that for E3D because we are a technology partner to Aviva, and we also have it for PDMS, which is the previous package. Both are well used all over the world. Then we also have it for CAEPIPE. Again, we have access to that database. We can take any changes to the stress model done by the stress engineer back to the 3D system, those 3D systems. I'm talking about E3D, PDMS, and CAEPIPE as what is called reference 3D geometry, so that the 3D designer can route the pipe again using those reference geometry. So there are a number of benefits. So in short, next slide please. Karthik?
Yes.
Yeah. CAEPIPE3D Plus includes, as I mentioned earlier, it includes CAEPIPE, full-blown CAEPIPE. It has got all the translators, not one of them, all of them that we have in our bag is there. And hot clash, check stress. All these are built into CAEPIPE3D Plus. And we also have a free reviewer we call it CAEPIPE Reviewer, where let's say the stress engineer does the stress model. He can give the stress model to the manager. The manager can download the reviewer free of charge. The manager can review the model, can plot the model, can print the model. All of that they can do, but they cannot modify the model. So they cannot perform analysis and modify the model. They can review all the results. They can review the details of the model. And as I said, it's got 85 we released the product, 84, 83 we started working on CAEPIPE. So it's been there for 38 years, well trusted all over the world. It's serving all of the industries. By the way, one of our biggest customers are all in the defense industry. Like now, for instance, you take Lockheed Martin is a big user of CAEPIPE for all their missiles and aircraft and all that. And Northrop Grumman, Boeing, NASA, US Navy for all their submarines and warships. So we are there, and of course we are very strong in dynamics. As you can see, it's integrated. We don't have a separate module for static and separate module for dynamic. And then we also have jacket pipe. Again, in many other software, you have to route the core pipe first, then the jacket pipe. So you have to do routing of the pipe twice. Whereas here, you route the jacket pipe along with the core pipe together. So there are a lot of advantages. So, and again, automatic load combinations are all done based on the code you select. Load combinations are selected automatically. So there are a number of advantages, and I would say this is the most, CAEPIPE3D Plus is the most comprehensive. It has got the data translator, it's got the check stress, it's got the hot clash, and it's very comprehensive. So if you have any further questions, I'm here to help you out.